Hi everyone, so today we're going to look at the new chapter, chapter 8, Physical Optics. So the first subtopic here is the Huygens Principle 8.1. Okay, what did Huygens Principle state adalah dekat sini by that statement here is every point on a wavefront can be considered as a source of a tiny wavelet that spreads out in the forward direction at the speed of wave. The new wavefront is the envelope of all the wavelets. So apa maksudnya adalah basically when you have a source, okay, ini source kamu akan produce satu wavefront. Maksudnya kita akan nampak that ripples lah kan, you're going to form a wave dekat sini. So wavefront ini what's going to happen adalah every point on this wavefront, setiap point and this wavefront akan menjadi a new source to produce a tiny wavelets based on that particular source. So basically setiap titik dekat sini akan jadi source yang baru dan produce many tiny wavelets. Okay, all these tiny wavelets spread out in the forward direction at the speed of wave. Then the tangent of all these wavelets akan produce a new wavefront, which kita panggil secondary wavefront. And this process continue. Every point on this new wavefront pula akan act as a source and produce many tiny wavelets, and then the tangent of the wavelet is going to produce another wavefront. This process continues. Inilah Huygens Principle. And then next kita nak tengok pada diffraction of wave through single slit and obstacle, and we're going to explain this menggunakan Huygens Principle juga. So what is going to happen dekat sini adalah bila kita ada satu plane wave tengah datang and then it meets a slit here. Bila dia bertemu dengan slit, apa yang akan jadi adalah kita akan ada point which act as a secondary source for the wavelet. So setiap titik ni akan act as a source pula. Dia akan produce a tiny wavelet dekat surrounding dia. After dia produce tiny wavelet, what's going to happen adalah in this part, the tangent of the wavelet is going to produce a wave which is plane wave, and then it's going to curve at the edge here. Dia akan curve dekat paling hujung situ. That produces the wavelets. Okay. Huygens Principle suggests that in conforming to the curved shape of the wavelets near the edge, the new wavefront bends or diffract around the edges, applied to all kind of waves including light. Sama juga macam case bila awak buka pintu dekat bilik. Contoh, dalam bilik itu gelap, tak ada cahaya. Di luar bilik itu ada cahaya. Bila awak buka pintu, apa yang akan jadi adalah cahaya dari luar akan disuluh masuk ke dalam, and then you're going to see part of the light is entering, and then that part pun, kalau ini pintu lah kan, ini bilik kamu, this is your bilik, and then this is the pintu. So apa jadi adalah you're going to remove this pintu now. You remove the pintu buka macam ni, cahaya akan masuk. Bila cahaya masuk, cahaya tak masuk straight sini saja. Cahaya akan bend. So sini semua pun kita akan, you can see the lights. Konsep dia sama dekat sini. Bending of lights occur as it meets a single slit dekat sini. Okay, cuma apa yang jadi dekat sini adalah when you have your gap between the slits here, kita panggil A ini, which is much smaller compared to the wavelength, iaitu the distance between the wave. Apa yang akan jadi dekat sini adalah you're going to get all curved ataupun circular wavelet. Kita tak akan nampak that plane lah. Kita tak nampak bahagian yang straight ini. Kita akan nampak semua curved wavelength. Itu bila when you have your A is much smaller than your wavelength dekat sini. Next adalah we're going to look at the obstacle part. Obstacle pun sama juga menggunakan konsep yang sama. Let's say you have wave, this is your wave here. Ini adalah plane wave kamu, dia tengah datang, dia bertemu dengan obstacle dekat sini. As it meets the obstacle, initially the waves wanted to move straight here. What's going to happen adalah we are going to produce a new source. Let's say kita panggil ini A, B and C ini. This A, B, C on wavefront, let's say I call this as a P, are close to obstacle. Wavelets are emitted from this point. So semua point A, B, C ni akan emit wavelets. These are the wavelets that dia emits. Okay. Wavefront, let's say kita panggil ini Q. Wavefront Q is the envelope of these wavelets and parts of it is behind the obstacle. Maksudnya, how did you get this wavefront adalah due to the tangent of these tiny wavelets dekat sini. And part of it berada di belakang kamu punya obstacle. Okay, this part dah masuk behind of the obstacle. You can still produce the wave. The new wavefront bends around the edge of the obstacle. As you're producing the wavefront, dia akan bend dekat bahagian dia bertemu dengan obstacle itu. Okay, yang penting kita kena faham konsep Huygens Principle dekat sini, iaitu you're going to have source and then you're going to produce a wavefront, and then every point on the wavefront is going to act as a new source, and then dia akan produce tiny wavelets, and then the tangent of the wavelet is going to produce a new wavefront, and the process continues. Okay, next we're going to continue with our next subtopic 8.2, constructive and destructive interference. Okay, apa itu interference? We know that meeting of two waves, they combine and produce a new wave. So, as we know that when one wave is traveling, let's say one wave is traveling, it meets with another wave, dia akan produce a new wave, di mana in this particular point the interference can occur constructively ataupun destructively. For constructive interference, maksudnya adalah bila crest bertemu dengan crest, dia akan produce a new wave with a maximum amplitude. So the amplitude is going to amplify, iaitu dia akan bertambah, dia akan produce maximum dekat sini. For destructive interference pula adalah bila satu wave bertemu dengan lagi satu wave, di mana the crest is going to meet the throw here. So bila mereka bertemu begini, what you're going to get adalah you're going to have cancellation of the wave. Maka kita akan dapat amplitude being cancelled, so kita dapat no wave form dekat sini. So ini adalah amplitude kita A, bertemu dengan A, you get 2 kali A. Your amplitude becomes a bigger. A darab dengan 2 kali amplitude. Whereas dekat sini A plus with negative A, you get 0. This is what we understand about the interference of wave by constructive ataupun a destructive dekat sini. So we are going to look at in our syllabus here, we must know that the source that we have must be a coherent source. Dalam syllabus kita kena ada coherent source. Apa maksud coherent source dekat sini adalah the source must have same wavelength and also frequency. Wavelength of the two wave must be the same and the frequency kena sama. Maksudnya kita ada wave yang pertama. Wave yang pertama dia akan ada lambda 1, dia akan ada frequency 1, wave 1. Wave yang kedua pula dia akan ada lambda 2, frequency 2. So your lambda 1 must equals to your lambda 2 and your frequency 1 must equals to your frequency 2. So kita akan ada this one here. So ini maksud coherent. Another thing adalah dekat sini adalah the coherent source must have constant phase difference. Perbezaan fasa antara dua wave itu kena constant. Must be constant. So it doesn't matter kita tukar ke posisi mana pun, perbezaan fasa antara dua wave itu sentiasa sama. Kalau by one wavelength, dia akan always one wavelength. Kalau by half wavelength, sentiasa half wavelength dekat sini. So constant phase difference dekat sini indicates that perbezaan fasa antara dua wave sentiasa sama. Okay, next adalah condition of interference of light. Dalam syllabus kita, the interference of light must obey these two conditions. The first one adalah the wave must be coherent and the amplitude of the wave is comparable, equal. Okay, wave must be coherent maksudnya kita berbalik ke sini. Kita punya syllabus, when the light interfere, syaratnya adalah mereka punya source must have the same wavelength, same frequency and must have constant phase difference. Itu adalah condition for interference of the light. Next adalah amplitude of the wave must be comparable, equal. So every wave yang kita produce, dia kena ada amplitude juga. So this amplitude of first wave must equals to the second wave. Amplitude adalah this part here, tadi kita lukis. This is your A here. This is your A here. This amplitude must equal for your both the wave. Kena ada amplitude yang sama. Dua-dua kena A juga dekat sini. Okay, itu maksud amplitude yang sama. So what is path difference ataupun phase difference dekat sini? Path difference adalah perbezaan jarak antara dua wave from the source to a particular point. So contoh dekat sini kita ada dua source iaitu S1 dan juga S2. Dua-dua source ini akan produce wave. Wave itu akan travel dan dia akan pergi ke satu titik yang kita nak, iaitu titik P dekat sini. This is the point that we are looking for. So both the source has to travel to reach point P. So kalau kita tengok the blue line here, biru ini indicates that daripada S1 ke P adalah sebanyak X1, daripada S2 ke P adalah sebanyak X2 jaraknya. As we can see, tengok dalam mata kasar kita dah tahu panjang X2 lebih panjang daripada X1. It is much longer, which indicates that ada perbezaan dalam jarak yang kita lalui daripada source 1 ke point P dan juga daripada source 2 ke point P. So the same thing is going to happen bila wave travel, mereka pun akan ada perbezaan fasa, which we call phase difference between the wave. So let's say you have from wave source 1 here, wave kamu tengah travel 1 wavelength, 2 wavelength, 3 wavelength, 4 wavelength, 5 wavelength, 6 wavelength, 7 wavelength. So it takes 7 wavelength to reach point P. And from S2 pula you have 1 wavelength, 2 wavelength, 3, 4, 5, 6, 7 and 8 wavelength. Kalau tadi 7, sekarang ada 8. So perbezaan fasa antara mereka sebanyak 1 wavelength. So the path difference can also be calculated from here. So kalau kamu tengok, this is the right angle triangle here. This right angle triangle here, the length here indicates the path difference between the first source and the second source dekat sini. So as you can see, perbezaan fasa dekat sini adalah sebanyak 1 wavelength. Samalah dengan apa yang kita ukur tadi itu. Selain daripada itu, delta L here, the path difference can be calculated as jarak daripada S2 ke P minus with S1 ke P, which is X2 minus X1 dekat sini. Okay, next we are going to look at the condition for constructive interference. So, kita tahu constructive interference maksudnya bila dua wave bertemu, constructively they are going to produce a new wave with a maximum amplitude lah. Contoh dekat sini kita ada ini sebanyak amplitude A bertemu dengan another amplitude A, kita dapat 2 kali amplitude. Ini maksud constructive interference. The interference is going to cause in the double of the amplitude for your wave itu. So, kalau kita tengok dalam constructive interference, kita ada 2 jenis, iaitu the coherent source kita ada can be in phase ataupun the source that we have can be anti-phase. So, as we know, we have slit here. The slit here is going to have 2 different source, S1 dan juga S2. The S1 and S2 can be either in phase ataupun anti-phase. Macam mana nak tahu dia in phase ataupun anti-phase adalah bila dia in phase, maksudnya permulaan dia daripada S1 berada pada fasa yang sama. Kalau kamu tengok dua-dua berada crest bertemu dengan crest. This maksud dia in phase. Kalau anti-phase pula, kalau kamu tengok source 1 dia adalah throw bertemu dengan S2 iaitu crest. So throw bertemu dengan crest. Ini indicate adalah, this is indicating that there is difference in the phase dekat sini. So in phase adalah bila dua-dua wave kamu itu starts with the same phase. Antiphase is when both your source here is going to produce wave that starting with different phase yang berlainan. However, mereka adalah constructive interference. So, hujung ini, dekat bahagian hujung ini, when they reach the point yang kita nak kaji itu, iaitu point O, they must meet constructively. Maksudnya crest kena bertemu dengan crest ataupun throw kena bertemu dengan throw. It doesn't matter however they started, either in phase ataupun anti-phase, tapi penghujung itu kenalah constructive, iaitu crest dengan crest ataupun throw dengan throw. So let's look at this particular point here. In phase constructive interference, kita ada from S1, 1 wavelength, 2 wavelength, 3 wavelength. Daripada S2 pula 1 wavelength, 2 wavelength, 3 wavelength. So delta L here is equals to S2 2.0 minus S1 2.0. Kita dapat 0 wavelength perbezaan antara mereka. But it doesn't matter. Contoh kita tukar sekarang titik, kita pergi ke sini. Let's say you change to here, here ataupun mana sekalipun, bila you tukar, since they started in phase dan mereka kena habis constructively juga, at every point dia kena habis constructively juga. So perbezaan fasa antara mereka akan sentiasa is either 0, lambda ataupun 2 lambda dekat sini, which indicates that constant phase difference here adalah sebanyak delta L is equals to M lambda, where your M can be 0, 1, 2, 3 or any number dekat sini. Okay, for anti-phase in constructive interference pula, as you can see here, they started in different phase. So you're going to have 1 wave here, 2 wave, 3 wave, 3.5. Kita ada 3.5 dekat sini. 1 wave, 2 wave, 3 wave dan 4 wave dekat bawah. So the difference between these 2 waves adalah sebanyak lambda over 2. And the difference here, if you change the point sini, O tak duduk sini, katakan O duduk sini atau anywhere along the screen here, kita akan dapat perbezaan dia sebanyak is either lambda over 2, 3 lambda over 2 ataupun sebanyak lambda. Which in general, dia punya delta L here is equals to M plus half lambda, where M here can be 0, 1, 2, 3 atau any number here. Okay, you have to remember, dia kena N constructively, iaitu cross bertemu cross ataupun throw bertemu throw. Tapi kalau in phase, dia kena start dengan fasa yang sama, anti phase dia start dengan fasa yang berbeza. Maka equation dia pun berbeza dekat sinilah, sebab kita dah cakap tadi syarat untuk kita punya syarat untuk kita punya interference of light adalah wave must be coherent. Apa maksud wave must be coherent dekat sini adalah satu, same frequency, same wavelength, iaitu the next one adalah constant phase difference. So perbezaan fasa antara dua wave kena sentiasa constant, kena sentiasa sama. It doesn't matter dia nak bertemu dekat mana titik sekali pun. So perbezaan antara mereka kena sentiasa constant. Kalau sebanyak kosong, kena sentiasa kosong. Kalau sebanyak lambda, so kena sentiasa sebanyak lambda dekat sini. Next, kita nak tengok pada destructive interference. Okay, as you know, destructive interference, kita dah sangat-sangat aware, when the two wave meets, they are going to destruct the wave here. Maksudnya, salah. Dia bertemu dekat sini, iaitu the crest here is going to meet with the throw here, and you're going to end up with no amplitude cancellation of the wave dekat sini. Ini maksud destructive interference. So sama juga dalam destructive interference, you're going to have in phase coherent ataupun anti phase coherent source dekat sini. So your S1 and S2 is going to be either in phase ataupun anti phase. Okay, so sebelum kita tengok in phase anti phase, kita tengok balik untuk destructive interference. Titik yang kita nak kaji itu dekat titik O sini, the wave here must meet crest dengan throw. Dia kena bertemu crest dengan throw, baru dia boleh destruct. Dia akan cancel the wave dekat sini. However, permulaan dia boleh jadi the source either they have in phase, iaitu sama fasa, crest bertemu dengan crest, ataupun dia boleh jadi anti phase, di mana throw bertemu dengan crest ataupun crest bertemu dengan throw. Mereka bermula pada fasa yang berlainan dekat sini. And as you can see here, to find the path difference for in-phase destructive interference, kita ada S1, 1 wavelength, 2 wavelength, 3 wavelength, 3,5. S2 kita ada 1 wavelength, 2 wavelength, 3 wavelength, 4 wavelength dekat sini. So beza sebanyak lambda over 2 dekat sini. The difference between them is by half the wavelength. So in general, the equation become M plus half a lambda. Whereas for destructive anti-phase dekat sini adalah permulaan mereka tidak sama sudah. So you have 1 lambda, 2 lambda and 3 lambda here. And the next wave is 1 lambda, 2 lambda, 3 lambda juga. Sama-sama 3 lambda, tapi mereka bermula pada fasa yang tidak sama dan mereka berakhir destructively. So you're going to get the difference between them dekat sini adalah, for this case adalah 0. Can also be 0 lambda ataupun 2 kali lambda. So what you're going to have adalah the delta L here is by M lambda here. Okay, so you must understand the condition for constructive and destructive interference respectively for their types of sources dekat sini. Types of sources boleh jadi in phase ataupun anti phase. A conclusion that I can make ataupun summary yang saya boleh buat dekat sini adalah, based on what you have, kamu akan ada interference kamu, your source here, you must have your source here. Ini source, interference kamu, interference kamu, dan juga kamu punya path difference. Path difference kamu dekat sini. So your source here can be either in phase ataupun anti phase. Dua je. Kalau kamu tengok untuk both the cases, constructive ataupun destructive interference sekalipun, construct ataupun destruct, kita ada dua je jenis, in phase, anti phase. So the source here has been divided into two types, iaitu in phase dan juga anti phase. Kita ada dua jenis. So dalam in phase, interference itu boleh menjadi either dia interfere constructively source kita in phase, interfere constructively, iaitu dia bermula pada fasa yang sama, dia berakhir constructively, ataupun dia in phase tapi dia interfere destructively, dia bermula pada fasa yang sama, dia berakhir destructively. So your in phase can have two types of interference, iaitu constructive ataupun destructive. Okay, for constructive interference, the path difference adalah sebanyak m lambda. For destructive interference, dia adalah m plus half lambda dekat sini. Alright, and then next kita ada antiphase dekat sini. And for your antiphase here, sama juga dalam antiphase source, kamu ada dua jenis, iaitu antiphase, dia boleh destructive interference, bermula pada fasa yang tidak sama and interfere destructively. It can also have antiphase constructive interference, bermula pada fasa yang tidak sama and then they interfere constructively dekat sini. So sama juga, so kamu akan ada constructive dan juga destructive, constructive and destructive. Your equation here, the path difference here terbalik dengan yang in phase tadi. So untuk tadi in phase construct adalah m lambda, sekarang antiphase construct akan jadi m plus half lambda, whereas your destructive antiphase become m lambda. So mereka terbalik. So tak payahlah hafal banyak-banyak, hafal satu je. Untuk in phase, hafal in phase dekat sini. Constructive m lambda, destructive m plus half lambda. Kalau dia antiphase, dia terbalik sahaja. Constructive jadi m plus half, destructive jadi m lambda. Alright. Okay, itu sahaja untuk 8.1.